Given two functions f and g that are differentiable on their respective domains, then the following is true. What I mean is, assuming that you can differentiate anywhere on their domain, you can say this. So here's a product rule. It's on the formula sheet I sent you. So we have two functions being multiplied together, and you want to find the derivative of the whole thing at once. I'll put a little quote there. Then you would use this formula. The derivative of the first function, f, times the second function, plus the derivative of the second function, or g, times the first function, f. So if we just always have it in this order, you'll always get your answer. Quotient rule. If you have f divided by g, and you want to take a derivative, then we get f prime times g minus g prime f divided by g squared. So the g function squared, whatever that is. All right. That's what we're going to need for 3.3. So problem one from the homework, find the derivative of y equal to x squared plus 3 times x squared minus 8x. So you can see that you could multiply it all out, right? And then do the derivative term by term. You technically could do that. But once the functions get really big or strange or complex or just impossible to multiply, you have to do the product rule. So like, let's say there was a seventh power right here. Like there's no way you're going to multiply this 7 times and then times this, and then take the derivative of every single term. Like that would be stupid, right? But this one you technically could because they're very simple. You could multiply it out, then do it like we did 3.2. But let's pretend we can. Right. Write down f. All right, let's call the first one f and this one g. Which one you choose for f and g don't matter. I always recommend do the first one for f, second one for g. That way it's always the same. So there's f. What is the derivative of f? What is the derivative of g?
Hold on, I'm just writing this down. Derivative of f, I would say is are we factoring?
You can't factor that.
Oh.
I think the derivative would be 2x, right?
Yeah, derivative of the first term is 2x.
Um,
Derivative of this one would be 0, right? So just 2x. What about this one? The parentheses don't matter. You can not write them, or you can ignore them.
is this 3x?
This one right here.
Yeah.
I
So do you remember what to do with the power rule?
Oh yeah, power roll, power roll. Yes, it's 2x.
3x power 2 minus 8, I believe.
2x minus 8. Yes.
Yeah, so this one will lose its x.
Trick question.
Yeah, there's our derivative. If you want to see the steps, you can do that. But last time, remember I showed you that you bring down the number, bring down the power, and then you subtract one, right? So bring down
No,
the
I use the power rule in physics all the time, so I'm familiar with it.
yeah, that's all it is. All right. So the derivative we said is f prime g. Actually, I'm gonna write it down here. F prime g plus g prime f. Okay, so just plug it in. F prime g plus g prime f. At this point, the calculus step is done. We found the derivative.
Okay. Now what?
Fine. Do algebra.
Oh, of course.
So distribute, right? 2x times this, 2x times that. Here we got to do a FOIL kind of thing, or if you prefer, we can show an extra step. Don't matter. You don't have to. You skip a few steps in algebra, that's okay. I like doing this for my algebra students because it makes it a lot easier to do instead of trying to do a box method or FOIL or whatever the hell. Who cares? It's all the same, really, right? Combine like terms and we're done. To get 4x cubed, negative 16 minus 8. Any questions on the algebra?
No questions on the algebra right now. I'm just finishing up here.
Okay. That's the first one.
Okay.
So that was a product rule. Anyone else have any issues or concerns? I'm gonna go look for the next one while you think about it.
No. I Oh yeah, I can't seem to find the formula sheet on Remind. I'm
All right.
looking at all
Right there on the chat box, just download it real quick. That fine. Does that work for you?
chat box. Yes, yes.
Where is it? Oh, here it is. Here's the calculus I sent last time, and here's some algebra properties if you want them. Don't matter. So here you can tell you have to do product rule. Stick with life. So 3e to the x times cosine. So what should my f function be?
Three.
I mean, technically you could, but you can treat this as one.
Okay.
That way we don't have three pieces. Instead, we have two pieces. You see what I mean?
Yeah.
But technically you could. But I prefer you think of it as like factoring three out and just disregarding it, or bring it along for the ride. Either way works. All right, what is the derivative of 3ex?
3x.
Yeah, it doesn't change, right?
Yeah. Doesn't change.
Yeah, like so.
Derivative of cosine, you don't remember?
Negative sine
Minus
x.
sign.
Yeah, minus sine. Okay, so we got everything we need. I always write the formula every time, that way I can memorize it. So f prime g plus g prime x times f. Let's just plug it in and we're done. Might have to do some algebra, but here we go. 3ex times cosine plus negative sine x times 3ex. Now we could technically factor this, right? I'd say this is the pretty back of the book answer. But this is like the answer most people are going to get, and then they need to simplify, right? I skipped an algebra step here. Any questions on problem 2 here?
No.
Okay. All right, let's move on to the quotient rule. So that was a product. Quotient rule is a little more annoying, but it's not too bad. Use the quotient rule. So it's going to be x over x to the fourth plus 7. So what is the f in this case?
Um, will it be
Is it just X?
X.
Yeah, just the numerator will always be x, or what
Oh.
was the top part is f. The bottom part is g. What is the derivative of x?
1.
1 and g prime?
G prime would be
4X?
4x cubed plus 7.
Well,
Oh
this
no,
would-
or just 4x cubed. I'm sorry.
yeah, this would be 0, right?
Yes, it would be 0.
All right, so let's use our formula and fill in the blanks. Not too bad, right?
Right.
So we said it's going to be f prime g minus g prime f over the g squared. Okay. So f prime is a 1 times g, which is this, minus g prime, which is 4x cubed times x. Oh, we're almost done. Running out of space though. This will be x4 plus 7 minus 4x4. I don't think it matters if we FOIL this out. I think homework is cool with you leaving it like this. Pretty sure. So final answer would be negative 3x to the fourth over x4 plus 7 squared. Any questions on the quotient rule?
Just gonna write this down real quick.
I have a question.
Mm-hmm.
So where is the plus 7?
Oh yeah, I forgot it, huh?
Okay.
You're right. I don't know where it was.
No questions.
Ready?
Yeah, I'm ready.
Prime of 0. Let me check the homework really quick. All right. So we'll move on to number 5. It's example 4. Find f prime and f prime at C. Let's call it Y, that way we don't get all confused. So given y of x equal to x cubed plus 2x times 5x to the fifth plus 4x minus 5. All right. So first step is do y prime. Right?
All right.
Let's make some space first. So once you find the derivative, all I want you to do is plug in c. In this case, c is equal to 0. Okay, so what should be f?
Hold on. There. I would say f would be 3x squared.
Yeah, first one, right?
Mhm.
X cubed plus 2x will be f. G will be x to the fifth plus 4x minus 5. So what is the derivative of f?
3x squared plus 2.
Plus 2, and g prime will be right. Excuse me. Alright. So y prime is equal to f prime g plus g prime f. So find your derivative, so that's going to give us 3x squared plus 2 times g, using this ugly thing. Okay, so we have to do multiplication, and life sucks. Make some space. So 3x times all this garbage, 2 times all that garbage. That'd be 3x squared times 5x to the fifth plus 4x minus 5 plus 2 times 5x to the fifth plus 4x minus 5. Plus 25x to the fourth times all of this plus 4 times that same garbage. Running out of space. So that will be 15x to the 7th plus 12x cubed minus 15x squared plus 10x to the 5th plus 8x minus 10. It's the second one. Multiply these right here. That'll be plus 25x to the 7 plus 50x to the 5th plus 4x squared plus 8x. Okay, there's all the multiplication. Combine everything.
Hold on,
Only-
for the first one, I think you forgot the to put the X after the 2.
Let's see. Which two? First line?
No, not the first line, like the third equals sign as you're going across before the 5x to the power of 5, there's just a lone 2. I think you meant to put the 2x there. Wait,
Here?
yes.
No, it should be it's a 2.
Oh, okay, okay.
The derivative was a 2. Yeah.
Okay, okay.
But yeah, let me double check everything just in case. Yeah, we're good. Combine like terms. 15 plus 25. Fifth is the next smallest one and the only one. Third is the next one. It's the only third. Squares. Oh, actually, there's another fifth. Would be 60. Squares. Negative 15 plus 4 is negative 11.
Wait, I think there's the 4x squared is supposed to be 4x cubed. And the 12x cubed and the 4x cubed are supposed to combine because the 4 on the outside of the
Oh yeah, right here.
parentheses.
3. Dang it. Okay, so that's 3. Let's fix that. Thanks for telling me right away. Appreciate it. Better now than later. Okay. So this would be 4 and 12, 16. Okay. Then the twos would be negative 15. Is it the only square? Looks
I
like
think
it.
so, yeah.
Mhm. And then the x's would be 8, 8. Yeah. Constants. Just the 10. Right?
That's the same answer I got.
That makes me feel better. Let's see. Now they want, so that's our derivative. That's y prime. So now y prime at 0. Everything would 0 out except negative 10, right? So for the first answer, part A would be this, part B would be that. The -10. Let's check. No, I don't have answers. Any question on this last one? It was just a complicated product rule, and then you got to plug in a number. The only real difference.
Where'd you get the -10 from?
If you plug in 0, they want us. They remember they said plug in C.
Yeah, they said plug in C.
So once you find your derivative, which is right here, find the derivative, plug in 0, or plug in C, you're gonna get -10 because 0 would zero every single term out
Oh, okay.
except that.
Forgot about that part.
That's pretty much it.
No further questions.
Hmm. I'll do one more and then I'll leave the rest to you. At least for that section. Find the second derivative. The 3/2. Okay. So first derivative, it's a single quote. You bring down the 3/2, subtract by 1, right? That'll give us 21/2 times x to the 1/2. Now one more time, a second derivative. So you would take what you just got and do it again. You'll bring down the half, subtract 1. We get 21/4 x to the -1/2. Which is going to be 21 over 4x to the 1/2, which is the same as 21 over 4 square root x. These are all the same. And if you were to rationalize it, you would get this guy. This would be the pretty back of the book answer, but I would accept either one of these. But yeah, if you see two quotes, just do it again. Now, any questions on product rule, quotient rule, or multiple derivatives? You see what they mean when they ask those things?
Yeah, I'm just gonna finish writing this down. Okay, we can move on now.
Right. Right, go to the next section. No questions on 3.3.
No.
I have a question.
Mhm.
So the last part, is it what kind of formula is this?
Oh, to get to here,
Mm-hmm.
let me show you the step. So it's called rationalizing the denominator whenever you have a square root at the bottom. They usually don't like square roots down there. So you kind of force it to square by multiplying by a form of one.
No, actually, my question is the before. So
Before
21
this.
over 4x minus 2 minus 1 over 2. Yes.
Oh, from here to here?
Mhm.
Oh, okay.
Actually, from the more before the 21. Yes, yes.
Oh, okay, sure. So, if there's a negative power, that means you could bring it down to the denominator, right? This one was already down there. So what I did is brought them to the bottom together. So remember, the negative powers means 1 over positive version, right? So this becomes 1 over this. So the little in between step would be this.
Okay. Now I get it. Thank you.
You know what I mean? Yeah. So I went from here to here, but this is technically what's happening in the background.
Thank you.
Yeah, no worries. Okay. Wait just a moment. Right. 3.4. All right, so this is the easiest way to think of the chain rule. It's one of the harder ones to kind of understand at first. It's just kind of strange. So given two functions, f of x and g of x, and the composition y of, we'll call it y of x. Composition will be y of x equal to f of g. Where f and g are differentiable. Then the following is true. So this is how I think of the formula. If you want y prime, what you do is do the derivative of the outside function, leave the inner one alone, and then multiply by the derivative of the inner function. If you do it this way, then it's always going to work out. You just have to identify what's the outer, what is the inner, and you can have function within a function within a function. You can have n functions, doesn't matter. But let's start with just 2. Because if we think of 3 or more, it starts getting weird. We have a big giant chain. So hence the name. We're chaining the derivatives because of composite functions. All right, so example 1. Just trying to get you to understand what is the inner and what is the outer. So y of x is equal to f of g, which is equal to 3x minus 7 squared. What is the f and g? What's the outer function?
Is it x squared?
Now you see how it's something being squared, so the outer is a squaring function. What's the inner function? Just this,
3x minus 7.
yeah, just this inside piece, right? Okay. So in the homework, they want you to identify this. They try to relate it to, what's it called? Well, it's related to composite functions. So trying to identify the inner and outer kind of helps understand. So they're doing substitution. So if the inner is u, that would be simply 3x minus 7. The outer function would be u squared. So the total will be 3x minus 7 squared. Does that make sense? What they want you to identify? The way I think of it is this way, but it's the same thing how they ask you to answer it. They just use different substitutions. Anyway, let's go to actually do the work now. Find the derivative. So y of x is equal to 2 times 5 minus 7 x to the 5th. All right, so again, what is the inner function? What is the outer function? Let's do outer first.
What's power 5 is going to be outer one?
Yeah.
Would it be 2x to the fifth power?
Yeah, we might as well bring along the 2. But yeah, 2x to the 5th. And what's the inner?
5 minus 7x.
Yeah, 5 minus 7x. What is g prime? What is f prime? We need it in the formula, right?
5 prime would be 10x.
This would be yeah, 10x4, right? And this one.
Would it just be -7?
Yeah, that's it. So we said to find the derivative, we got to find the derivative of the outside times of the inside times the derivative of the outside. So what is f prime of g?
Well, if prime of g, that would be like you're basically taking 2x5 and putting the -7 into the x.
Yeah, so here's f
And
prime.
x power 4 times 5 minus f7.
Oh, I didn't got distracted. Sorry.
No, you almost had it. I think I saw the wheels turning there. So it would be instead of 7, you meant this one, right?
Yes.
Okay, now times g prime. So that's just -75 minus 7x to the 4th. So whenever I do this, I've done it so many times, I'm just like, well, just take the root of the outside, bring down the 2, bring down the 5 times 2, subtract 1, ignore this, and then do the root of the inside, which is right there. I don't really do this part anymore, but after you do it many times, you start to see what the pattern is. But this helps kind of first understand the first time. Any questions on number 2?
No.
Let's do another one. Very similar one till we get comfortable. Find the derivative. So I'm just going to keep calling them y. That way we can use the same formulas. So we said y prime is equal to the derivative of the outside times the derivative of the inside. So what is the outside function?
X to the 2/3.
X 2/3. And then we'll do the derivative in a moment. What is the inner function?
Nine x plus 4.
Yeah. What is f prime?
Is it 2/3 X to the 1/2?
2/3 x. 2/3 minus 1 would be -1/3. Right, because we 3/3. Okay. And then g prime will simply be 9, right? Okay. So y prime will be 2/3 of g to the negative third times the g prime. Any issues on where this came from?
So again,
Any questions on how we got here?
no.
All right, let's do some algebra and finish it off. 2/3 times 9, that would be 6, right?
Right.
Bring this down to the bottom because it's a negative power. So that'll be 6 over 9x plus 4 to the 1/3. Or if you prefer, cube root of 9x plus 4.
Okay.
Sorry, I got distracted. Another one. Until the chain rule starts to make lots of sense. It's problem 8. Okay. Whenever you see a radical like this, I recommend you first start by rewriting it as a power. Remember, x to the m over n is equal to the nth root of x to the m, or the nth root of x, the whole thing to the m. Same thing. All right. So what is the outside function?
X to the third power, X to the 1/3 power.
Yeah, x 1/3 inner function.
6 squared plus 7.
Yeah. All right. What is f prime?
Is it 1/3 x to the negative 2/3?
Yeah, yeah. 1/3 x negative 2/3. And g prime. Not too bad, right? Okay. So what is f prime of g?
Is it 1/3 and then in the parentheses it's 6x squared plus 7 all to the negative 2/3 power?
Yes, that'll be, like you said, 6x squared plus 7 to the negative 2/3 times g prime. Okay. So this is negative, so bring that to the bottom. 12x over.
Where did the 1/3 go? I think it's supposed to be in front of the parenthesis.
Yeah, you're right. We'll put it down here instead. Okay, and then if you want to use radicals, you could use 12 divided by 3 is 4, so that'll be 4x, right? If you want to use this in radical form, that would be cube root of 6x squared plus 7 squared, or these, all three of these should be fine. Any questions on number 4?
Hold on, just let me write this down. Okay, you can move on. No further questions.
1 second. So one last one, and then we'll stop for the night unless you have questions. Same stuff, but this one's a little harder. Find y prime. So notice, what do you notice about this question? Well, how would you find the derivative?
Then we should use the power rule on x power 2. We kind of simplify it, and then we're gonna use the chain rule.
You'd have to do all of it at once. So you have to do the product rule, but during the product rule, you're gonna have a chain pop up. You see what I mean?
Yeah, kind of.
Yeah, so this is a little, there's 2 rules at the same time. And during those rules, we have all the power rules. So This one's really testing. Do you understand all of 1 through 4? All right, so let's call f the x squared. F prime would be 2x. G is the square root function. But G prime is going to be the difficult part. So G prime is going to be, well, first we got to rewrite it. So G prime, bring down the 1/2. But then you have to multiply by the derivative of the inside. See what I mean? So this time I'm doing it all at once instead of showing out the pieces. At least for the chain part, not the actual question. So here's the outer derivative, right? Bring down the 1/2, subtract 1 times the derivative of the inside, which will be 2x, right? Simplify this, 1/2 times a 2, that'll be negative. This will be negative x over 9 minus x squared to the 1/2. Any issues with this part?
I think you forgot you meant to put the multiplication dot outside of the parentheses with 2x.
Oh, this is a minus.
What's a minus? Okay.
All right. Any questions on finding the derivative for G? Because the G required a chain rule. Yeah, chain rule. We haven't done the actual question yet.
No. No questions.
All right. So y prime is going to be f prime G times G prime F. So that will be 2x times 9 minus x squared to the 1/2. Oops. That should be a plus G prime, which is your negative x over 9 minus x squared to the 1/2 times,
You screw your paper down.
oh yeah, of course. There we go. So there's f prime G, G prime F. So we're doing the product rule right here. So make a note real quick. G prime required a chain rule. This is the product rule. Now we just gotta make it pretty. We can rationalize this one. No, actually, we can make this one have the same denominator. That's what we could do. Technically, the calculus step is done. The next, all the rest is algebra. So multiply the top and bottom by 9 minus x squared to the 1/2. That way it has the same denominator as this one. And then I'll multiply the x times x there, x squared. Get negative x, oops. Cubed over this guy. Ready? These two would add up to 1, giving us 2x times 9 minus x squared. Sorry. All this wind is giving me allergy problems. Minus x cubed over 9 minus x squared to the 1/2, which gives us, distribute the 2x, that'll be 18x minus 2x cubed minus x cubed over this. All right. Finally, we're done. That'll be negative 3x cubed plus 18x over this denominator. Any questions on this? Is one of the harder ones. It's like the last question or two. But do you see that we had two functions here? So we have to set up a product rule, but during the product we have to do a chain. Once we have the chain result, we could plug it in into here. And then after that, it's just algebra, fractions and stuff.
Okay.
And any questions on any of those steps?
No. None for me.
All right, let me pause this and take roll, and then if you have any concerns or issues, let me know.